हेलो एंड वेलकम बैक टू फिजिक्स फॉर कॉज। मेरा नाम शिवम डंगवाल है। आज हम लेक्चर नंबर 1 में स्टार्ट करने जा रहे हैं इलेक्ट्रोस्टैटिक्स। जैसा कि पिछले वीडियो में हमने सिलेबस ऑफ क्लास 12 सीबीएसई बोर्ड को हमने जाना, फिजिक्स का किस तरीके से सिलेबस को हम अप्रोच करेंगे। सो पहले जो यूनिट है, यूनिट नंबर 1 इज इलेक्ट्रोस्टैटिक्स। इस यूनिट के अंडर हमारे एनसीईआरटी के दो चैप्टर्स कवर होंगे। चैप्टर नंबर 1 इलेक्ट्रिक चार्जेस एंड फील्ड, चैप्टर नंबर 2 इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस. So what are the topics which we will be going to cover in this particular unit, electrostatics? So here you can see there are several topics such as electric charges, conservation of charge, Coulomb's law of force between two point charges, forces between multiple charges, superposition principle, continuous charge distribution, electric field lines, electric field due to a point charge, electric dipole, electric field due to dipole at axial equatorial position, torque on dipole in uniform electric field, electric flux, statement of Gauss theorem, and its application to find the field due to infinitely long straight wire, uniformly charged infinite plane sheet, uniformly charged thin spherical cell, the cell in which the charge is filled inside and outside as well, electric potential, potential difference, electric potential due to a point charge, dipole, system of charges, equipotential surfaces, electrical potential energy of the system of 2 point charges, and of electric dipole in electrostatic field. We will be going to cover conductors and insulators, free charges, bound charges inside a conductor, dielectrics and electric polarization, capacitors and capacitance, combination of capacitors in series as well as in parallel combination, capacitance of a parallel plate capacitor with dielectric medium between the plates, energy stored in the capacitor, and Van de Graaff generator. So these are the topics which we will be going to cover in this particular unit, electrostatics. So let us begin with the branch of electromagnetism. So this is the supreme branch, electromagnetism. It covers two sub branches. Number one is electrostatics and second one is electrodynamics. As the name suggests, if we are going to talk about the electro, the meaning of electro here represents about the charge. So charge. And statics means the charge is present at rest. In the same way, if we talk about the electrodynamics, so electro here refers to the charge and dynamics here refers to the motion. So I hope it makes you very clear that electromagnetism is being divided into two subcategories. Number one category is electrostatics and second category is electrodynamics. Electrostatics covers the study of charges at rest and electrodynamics covers the study of charges at motion. Okay, so as our unit suggests, the electrostatics, so we will be going to cover these topics, charges at rest, electrostatics, in this particular playlist. Later we will cover electrodynamics in the upcoming videos. So what are the topics which we will cover about the electrodynamics? Here we study about the electric current. Here we study about the magnetism. Here we study about the electromagnetic theory. Electromagnetic theory covers the electromagnetic induction. Here we talk about the alternating current. There are various topics which we will be going to cover in the upcoming videos. So the first unit covers only about the electrostatics. Here we will be going to deal with charges at rest. So now let us begin what exactly is a charge. First of all, we need to understand charge, or most probably I would say electric charge, because we are going to align charge with respect to the electrostatics. So what is charge? Charge is an intrinsic. It is an intrinsic, or you can say basic, or you can say fundamental property of matter. It is the fundamental property. It is the basic property of any matter. And what exactly is matter? Anything that has mass and occupies space is referred to as matter. Okay? So charge is the basic property of matter. What is the symbol which we use to denote the charge? This is denoted by the symbol Q. In some books, it is denoted by small q. Both are same. Capital Q, small q. Charge is usually denoted by the symbol Q. What is the SI unit, System Internationally unit for the charge, which is widely accepted in the world? That is Coulomb. Coulomb, it is denoted by C. Why the unit of charge is Coulomb? Because this was explained by the physicist whose name was Coulomb. What type of a physical quantity it is? Physical quantity, or I would say type of physical quantity. So as we know that in physics, a physical quantity is divided into two categories. Number one is scalar quantity and second is vector quantity. As we know that scalar quantity covers those physical quantities which have magnitude only but no direction. No direction. But we are talking about the vector quantity. It covers magnitude as well as direction. If we are going to talk about charge, so what type of physical quantity it is? It is a scalar quantity. Scalar quantity, because it only has the magnitude. It only has the magnitude present, but no specified direction. No specified direction. That is why charge is referred to as a scalar quantity. We know that if I want to classify the charge, so charge can be classified as positive charge, negative charge. Simple. And one of the interesting property of the charge जो हम बचपन से पढ़ते हुए आते हैं, that is like charges repel each other. Repel each other. And unlike charges attract each other. Unlike charges attract each other. So if I talk about like charges, for example, positive charge and positive charge, these are brought close, so they will repel. रेपल का मतलब है यहाँ पर ये रिपल्सन फोर्स देंगे तो ये दूर भागने की कोशिश करेंगे. लेट मी चेंज द कलर. ये दूर भागने की कोशिश करेंगे, अपने आप से दूर भागने की कोशिश करेंगे. सो हेयर देयर इज अ फोर्स ऑफ रिपल्सन. इफ आई टॉक अबाउट नेगेटिव charge, so this is negative charge, this is negative charge, and if I brought it together, पास लेके आता हूं तो अगेन सेम थिंग हैपन. दिस इज द प्रॉपर्टी ऑफ चार्ज. ये आपस से दूर भागने की कोशिश करेंगे. दिस इज अगेन द फोर्स ऑफ रिपल्सन. सो लाइक चार्जेस रिपेल ईच अदर. दिस contributes to the force of repulsion between the charges. Okay. Unlike charges attract each other. If I talk about positive charge, if I talk about the positive charge and the negative charge, अगर मैं इसको पास लेके आता हूँ, they are made close brought towards each other, then what we notice, हम ये नोटिस करते हैं ये आपस में अट्रैक्शन फोर्स देते हैं. देयर इज अ फोर्स ऑफ अट्रैक्शन बिटवीन द टू अनलाइक चार्जेस. सिमिलरली अगर मैं क्या करता हूं, माइनस चार्ज एंड प्लस चार्ज को लेता हूं तो सेम थिंग हैपनिंग हियर. सेम थिंग हैपनिंग हियर. दीज टू आर अनलाइक चार्जेस, सो दे विल एक्सपीरियंस द फोर्स ऑफ अट्रैक्शन. So, unlike charges attract each other, this contributes to force of attraction between the two charges. I hope it is very clear. Now, what exactly is electrostatics? Electrostatics, the unit name is electrostatics. So it can be considered as a branch of physics. It is a branch of physics which deals with charges at rest. With charges at rest, जहाँ पर चार्जेस रेस्ट में है, उस ब्रांच की स्टडी करने को हम क्या बोलेंगे? इलेक्ट्रोस्टैटिक्स. जैसा कि मैंने अभी ऊपर बताया है कि इलेक्ट्रो refers to charge and statics refer to rest. So charge at rest refers to electrostatics. Now, what is the importance of electrostatics? Why we need to understand the concept of electrostatics? Why are we reading the electrostatics? Why are we understanding the electrostatics? क्यों पढ़ रहे हैं? Because it has several importances. Number one, electrostatic generators are based on the electrostatics as they produce voltage as high as 10 to the power 6 volts. 10 to the power 6 volts means 1, 2, 3, 4, 5, 6. This volt. See the difference. Such high voltages, these voltages are very high, and these are required for the X-ray work and nuclear bombardment in the field of nuclear physics. Second thing, we use principles of electrostatics for spray of paints, powder, etc. For example, if someone is working to paint a car or a surface, metallic surface or something like that, so they use the principle of electrostatics for the spray of paints, powder. As you can see these two concepts in this particular picture. Third importance of the electrostatics is to prevent the pollution. So the devices based on electrostatics to prevent the pollution are referred to as electrostatic precipitators. So these are the electrostatic precipitators which work on the principle of electrostatics. Fourth point, problems of preventing sparks and breakdown of insulators in high voltage engineering are essentially electrostatic. So the electrostatic branch of the physics is helpful to solve the problem of preventing the sparks or the breakdown of insulators in high voltage engineering devices. Fifth point, development of lightning rod and capacitor are the outcomes of the electrostatics. जब हमें इलेक्ट्रोस्टैटिक्स के बारे में समझ है तभी हम लाइटनिंग रॉड को डेवलप कर पाए हैं. Scientists and researchers were able to develop the devices lightning rod and capacitors which are the outcomes of electrostatics. लाइटनिंग रॉड आपने घरों में देखा होगा. लाइकवाइज दिस इज अ रूफ, और रूफ के ऊपर ये छोटा सा डिवाइस, छोटा सा तो नहीं कह सकते, एक सिग्निफिकेंट साइज का डिवाइस रहता है जो लाइटनिंग रॉड होता है. इसका फंक्शन क्या होता है? जो लाइटनिंग रॉड होता है, जैसे अगर यहाँ से लाइटनिंग हो रही है, बिजली कड़क रही है, तो ये क्या करता है? दिस प्रिवेंट्स द हाउस फ्रॉम बीइंग गेट इलेक्ट्रिकली शॉक्ड. ये पूरा शॉक ले लेता है और ये अंडरग्राउंड तक कनेक्टेड रहता है यूजिंग कॉपर प्लेट. So we will be going to cover the lightning rod in the last phase of this particular unit. So it's a very interesting concept. Okay. So we need to understand the topic of conductors and insulators very well. So what are conductors? Those substances through which electric charges can flow easily are referred to as conductors. For example, iron, copper, aluminium, these are conductors. And insulators, those substances through which electric charges cannot flow are referred to as insulators. So for example, if I talk about the example of insulators, paper, rubber, plastic, so these are the insulator. Now the important and the most interesting concept, frictional electricity. As the name suggests, friction. Friction कब होता है? When two surfaces are in contact. फ्रिक्शन का मतलब क्या है? जब दो सरफेस आपस में कांटेक्ट में होते हैं तो कांटेक्ट में तभी होंगे जब हम उसको रब कराएंगे अगेंस्ट ईच अदर, और वहां पर जो इलेक्ट्रोस्टैटिक चार्जेस डेवलप्ड होते हैं इंसुलेटिंग बॉडीज में, दैट इज रेफर्ड टू एज द फ्रिक्शनल इलेक्ट्रिसिटी. फॉर एग्जाम्पल, अगर this is the famous and the most easy experiment you might have done earlier. So अगर हम क्या करते हैं, हेयर कॉम लेते हैं, हेयर कॉम को अपने हेयर में रब करते हैं. हेयर एज वेल एज हेयर कॉम दोनों इंसुलेटर है, पेपर भी इंसुलेटर है. अगर हम हेयर कॉम को पेपर के टाइनी टाइनी पीसेस के पास लेके जाते हैं, लाइट वेट पेपर के टाइनी पीसेस को लेके जाते हैं, वी कैन सी द फोर्स ऑफ अट्रैक्शन बिटवीन द टू, एंड दिस इज इलेक्ट्रोस्टैटिक फोर्स. सो दिस इज बीइंग क्रिएटेड व्हेन टू सरफेसेस आर रब्ड अगेंस्ट ईच अदर. जब दो सरफेस आपस में रब हो रहे हैं, लाइक इन द केस ऑफ हेयर कॉम एंड द हेयर ऑफ अ पर्सन. Similarly, if I talk about the glass rod and the silk cloth, अगर हम glass rod को silk cloth को rub करें, then we can see the both are the insulators, but they are being get frictional charges. Likewise, the glass rod acquire the positive charge and the silk cloth acquire the negative charge. So this is the concept of frictional electricity which we will be going to use in this particular unit. Before moving further, we need to understand the unit of electric charge. So as the electric charge unit, I have earlier stated it is coulomb, and this is the scientist Coulomb who discovered about the electric charge, who gave the concept of the electric charge. So how can we define coulomb? So it is denoted by the symbol C, capital C. So 1 coulomb is the charge which is equal to the charge on 6.25 into 10 to the power 18 electrons. Okay. So see the significance of 1 coulomb. 1 coulomb covers the charge on 6.25 into 10 to the power 18 electrons. So if I can use the unitary method to find the charge on 1 electron, so I need to divide 1 by 6.25 into 10 to the power 18 electrons. Simple. जब 1 कूलम चार्ज के अंदर 6.25 into 10 to the power 18 इलेक्ट्रॉन्स है, तो चार्ज ऑन 1 इलेक्ट्रॉन निकालना है, तो 1 डिवाइडेड बाई 6.25 into 10 to the power 18 होगा. नाउ वी नीड टू सॉल्व इट. सो सॉल्व करने का तरीका यहां पर आप देख सकते हैं. So on division, we will get the charge on 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. So we can write charge on 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. So this is the charge on 1 electron. Okay. Now we need to understand the concept between the differences between electric charge and mass. So I would write here differences between electric charge and mass. So electric charge may be a positive quantity, it may be a negative quantity, or it may be neutral. So I would write 0. But mass of a body is always a positive quantity. Mass of a body is always a positive quantity. Electric charge is quantized. We will cover the quantization of charge in the next video, but quantization refers to packets of charges. Here n refers to the number of electrons, or I would say the packets of electrons as well, hypothetically. So electric charge is quantized, but quantization of mass is yet not established. Charge on a body does not depend on its speed, but mass of a body depends on its speed, and we know the relation m is equal to m naught upon under root 1 minus v square upon c square. So this is the relativistic mass formula. Here m naught is the rest mass and m here refers to the relativistic mass. C is speed of light and v is the velocity of or the speed of mass. So this concept was given by the Albert Einstein. Electric charge is always conserved. So here we talk about the law of conservation of charges. But if I talk about the mass is not conserved because it can be converted into energy and vice versa. Energy can be converted back into the mass. This was given by the famous energy mass equivalence relation E is equal to mc square by Albert Einstein. And this is read in another branch of physics that is referred to as spatial theory of relativity. Spatial theory of relativity. Electric forces between different charges may cancel out, but gravitational force between different masses never get cancelled out. If I talk about the electric charges, the force may be attractive or repulsive, as we have seen earlier by taking the example of different kind of charges: positive, positive, negative, positive, negative, negative, or positive, negative. We have seen the case of unlike and like charges, force of attraction and force of repulsion. But the gravitational force between the two masses is always attractive. So if I talk about this is Earth and this is a mass, so here if I drop the object towards the Earth, so Earth experiences a force of attraction, or the ball or the object which I have thrown, it experiences a force of attraction towards the center of Earth. That is gravity itself. So the gravitational force is always attractive in nature. So I hope that in this particular lecture you get familiar with the concept or the topics which we will understand in the unit 1. In the next lecture I will explain about the basic properties of electric charge, law of conservation of charge with examples, quantization of charge, and methods of charging, or we can say the transfer of charge, how charge get transferred from one body to another. Thank you very much for watching this particular lecture.